In this video, I'd like to talk about what are known as higher order derivatives. And I thought we'd just start by doing an example. So I have a function f of x, and if I just ask you to take the derivative, we could just go term by term and take the derivative. Done. But what I want you to do now is look at this. That's called f prime, but it's a function. 4x squared minus 6x squared plus 6x minus 2. And I'm just going to cover that up and say, hey, that's a function. Take its derivative. And I can. And now I just need a name for it. Well, if that's f prime, I'm going to call this f double prime. And then this gets the name first derivative. And this gets the very creative name second derivative. Since the derivative is a function, it itself has a derivative. And if there's a first derivative and a second derivative, I imagine there's a third derivative. All right, and that would be 24x minus 12. The constant's derivative is 0. And I'm going to take a fourth derivative. And instead of running 4 tick marks, that gets a little too complicated for us to tell visually, so we actually put the number of tick marks in a parenthesis. And if you're going to use this notation, please use the parentheses. Without that set of parentheses, it would look like you're raising that function to the fourth power rather than taking the fourth derivative. Well, the derivative of 24x is just 24. And if I want to take a fifth derivative, well, the derivative of 24 is 0. And then after that, the sixth derivative, seventh derivative, eighth derivative, they're all 0, right? Because the derivative of a constant is 0. And so I started with a function, and what I've done now is taken a derivative of every order, because they're all 0 from here on out. And so what I could write is that the nth derivative is 0 when n is bigger than or equal to 5. And now literally on this board, I have taken the derivative for every possible order. So this is first order, second order, third order. And so what I would say I've done here is I've found derivatives of all orders. Right? Because literally here, after I get to the fifth derivative, they're all 0, and I can clearly communicate that just with this equation and that inequality. Let's do another example where we find the derivative of all orders. All right, so let's say y equals 2e to the x minus 3x squared. Let's take derivatives and see if we can figure out what they are for every possible order. The first derivative, y prime, well, that's going to be 2e to the x minus 6x. Y double prime, 2e to the x minus 6. Y triple prime, 2e to the x. Y to the fourth, not y to the fourth, y to the, the derivative of the fourth order. I said that badly. 2e to the x. And from here on out, they're all 2e to the x. So the nth derivative, the derivative of the nth order is 2e to the x when n is bigger than or equal to 4. Here I have an example where my derivatives don't vanish. They don't go to 0 if I keep taking derivatives. I get 2e to the x if I keep taking derivatives. Okay, not every function works like this. Not every function will give me something where it's possible to actually write down in a nice way every possible derivative. So if I had y equals 1 over x, and I was asked to take as many derivatives as I want to, it's not very good set of instructions. I don't think I'm going to ask that way on a test, right? Because if on a test you said take as many derivatives as you want to, you should just do one. y prime minus x to the minus second. All right? And I want to write that as minus 1 over x squared. But when I go to take the second derivative, unsimplified is the way I want to do it, because now I just get to keep taking 1 away from the exponent and multiplying the exponent down. And I see that as I keep taking derivatives, there's a nice pattern, but they're not going to vanish and they're not all going to become a constant function that I'd have to keep taking derivatives using the power rule and the constant multiple rule. Okay, so we have multiple notations for the derivative. So I'd like to end this video just by going about how I can talk about these different orders of the derivative. So I know that y prime is f prime, is the same as df dx, is the same as dy dx, is the same as d dx of f of x. And then there are even more notations, but these are the ones we primarily use. So for the second derivative, I would say y double prime is f double prime of x. And now I'm going to hop down to this one, and what I would say here is that we're taking a derivative of a derivative, right? So I could write that like that, right? The second derivative of a first derivative, the derivative of a derivative. And if I combine those symbols, I'd actually write it down like this. And so this becomes a d squared f over dx squared. And here I have a d squared y over dx squared. And here I could just write that like that as a way to get down to that notation. So let's write down the third derivative. And then I think we'll have a good understanding of how to keep going if we wanted to. And if I wanted to write something down like this, I would be taking a first derivative of a second derivative. All right, so those are all the different notations I could use for derivatives of higher orders. This is a fancy way of saying the third derivative. In section 3.4, the book goes through and talks about these things in application, and I thought I'd just take a moment. There's a separate video posted in 3.4 about that from your textbook that does a really good job. But while we're talking about these derivatives of higher order, I could think about y equals f of x as a position function. Plug in x, get out of y. All right, well then if I take a derivative, y prime is f prime of x, well that should be an instantaneous rate of change. We could think of that as velocity. Velocity. Take a derivative, and that's a rate of change of a rate of change. That's what is known as acceleration. And then the third derivative of position is what we call jerk. Position, velocity, acceleration, and jerk all related to each other by taking derivatives. And again, I just wanted to mention those things here at the end of the video. There's a separate video posted in section 3.4 that really goes through these things in all the necessary detail. Bye for now.